In this video, I'm going to be talking about some introductory trigonometry concepts. So we're going to look at sine, cosine, tangent, kind of how to solve some triangle-related problems. And to start, I'm going to start with a fact that you definitely saw in your geometry class. And I don't know, you may or may not have proved this fact in your geometry class. I'm not sure. I haven't taught geometry in a while. But the interior angles of a triangle add up to 180 degrees, always, every time, every triangle. So if you know that, here you have, well, let's say that's a right angle, it's a 90-degree angle. And you've got, 60, then they need to add up to 180. So I've got 90 and 60 is 150, 30 more is 180, right? But it's not always so easy as that, right? Sometimes we don't know just right off the top of our heads. Like, what if I changed this instead of 40 to be like 37, and this to be, I don't know, 114. Oh, that didn't go well. Oh, bless you. All right, so then we would need to use algebra to solve the measure of angle theta. So what we would do is we say we know they add up to 180. So we could say theta plus 114 plus 37 is equal to 180. Well, so we'd have to combine like terms. You have to add the 114 and the 37. I think that's going to be 151. And then I would subtract the 151 from the 180 and conclude that theta was like 29 degrees or something. Okay. And it's going to be safe to assume for the rest of the problems on this video that the figure is not drawn to scale. I really only have 3 triangles I'm working with. I'm working with one right triangle, one isosceles triangle, and this kind of obtuse triangle. Right? I'm just copy-pasting them over and over again. So definitely don't go off of what you think you're seeing. Go by off of what the information given in the packet is. Right? Something that you also knew in your geometry class was that isosceles triangles were the type of triangles that have 2 sides that are the same length. Okay? And it's also a fact that the angles across from those sides will have the same measure. Okay? Because of really something that you're going to find out 2 times from now. We're going to look at law of sines. Is that, the size of the side is related to the size of the angle that's across from it. So if we know one of the angles and we know that a triangle is isosceles, then we can find the other 2, basically. So for this first one, this one on the left, I know that 50 plus theta plus another theta is equal to 180 degrees. Okay, well, that's 2 theta and 50 equaling 180. We start to solve. 2 theta is 130. And that makes theta equal to 65. This other one on the right, you would have to say, okay, well, if this is a right triangle, then this lower right angle must also be, did I say right? This is an isosceles triangle, meaning the lower right one has to be 50 degrees. I'm not sure if that's right. Okay, so then you go and you set up the same thing. Then you basically end up concluding that theta is 80 degrees. Now, okay, you look at that triangle, and you know this is not an 80-degree angle up at the top, right? Remember, the figures are not drawn to scale, that you have to just use the information that you're given to solve the problem. All right, next, I'm just going to remind you about a right triangle. A right triangle has one angle that's a right angle, which means that it's 90 degrees. Okay? So that means that this, down here in the bottom left, that's 90 degrees. And you see that little square in the angle, that generally indicates that we have a 90-degree angle. If we want to know the value of theta, now I kind of did this at the beginning, but with a little easier numbers. So theta plus 90, and maybe I'll change this up to make it a little more exciting. I'll change this to like 33 degrees. So theta plus 90 plus 33 is equal to 180. Okay, so that's theta plus 123 equaling 180. All right, you subtract the 123 and you're going to get 57. So it's a 57-degree angle. It actually looks kind of believable, maybe, kind of. And in all of these discussions, once we've found the angles of a triangle, we know its shape, right? That's what dictates the shape of a triangle, is the different angles. You know, if you think about that obtuse triangle, it was obtuse because it had one of the angles that was bigger than 90. And this right triangle, it looks the way it does because one of the angles is a right angle. But there are other right triangles. There's ones that are, you know, a little squarer than that. You know, like basically, you know, half square. And there are ones that are really, really kind of splayed out and like that. Okay, these are all right triangles, but they all have different shape. And it's all well and good to know the shape of a triangle, but if you're trying to find out everything there is to know about a triangle, which is basically what we're doing today, we're going to need to know the size of it as well. And we know that two triangles may have the same shape, but not be the same size. Just look at these two, you know. Here I've got one that's 2, 4, and 5, and the other one I know it's got a side length of 10, so I know they can't be the same size because, you know, I don't see any sides with length 10 on the triangle on the left. But if we know that they're the same shape and we know one side length, then we can use that information to find the other side lengths. So if I wanted to find, you know, what I call these like x and y are, well, to solve for x, I could use a proportion. Okay, I could say that since these are similar triangles, I could say that 5 to 10 is going to be the same ratio as 4 to x. Okay, and I could cross multiply, and I could say 5 times x is equal to 40, meaning that x was 8. Now, I mean, do any of y'all see maybe an easier way to figure out how x was 8? Yeah, just times 2. Okay. You can see that because you went from 5 to 10 by multiplying by 2, and they're the same shape, that the triangle on the right must just be twice as big as the triangle on the left. So to find y, I could just say, you know, y is going to equal 2 times 2, which would be 4. Okay. So instead of 2, 4, and 5, I have 4, 8, and 10. Because they're proportional triangles. So the point I'm trying to make here is that we can know everything there is to know about a triangle if we know its shape and one side length. Okay. Now if we think back, if I scroll back up to the right triangle case, okay, right, all we needed to know was one of these angles that wasn't the right angle, and we would know the shape. So for a right triangle, if we know one of the angles that isn't the right angle, and we know one of the side lengths, then we could solve for everything else there is to know about the triangle. Okay. Now we will have to be depending on, you know, some research some other people have done about different sizes of shapes of right triangles, but that's something that we can do. We can use that. We're going to use a calculator. We won't need to look up in the tables, but that's something you could do if, you know, you had no calculator. Okay, now I think it would be a good time for us to talk about our trig ratios. And it's, you know, kind of what I'll call these, the 6 trig ratios. Okay, that's sine, cosine, tangent, which, you know, I am presuming that everyone has seen at some point. But if you hadn't had pre-calculus before this course, then you might not know about secant, cosecant, and cotangent. But don't worry, I'll show you how to deal with it. Okay, so we go back and, okay, we've got our adjacent, opposite, and hypotenuse sides of a right triangle. Okay? The hypotenuse is always the longest side of a right triangle. It's the one that's across from the 90-degree angle. And theta is like the one that we're going to call our reference angle. It's the angle that we know, that we're given. Now, of course, it's not hard to find the other one, but we're just going to start with this theta right here. Okay? You just kind of envision yourself being, you know, like a little person sitting inside the triangle, right? Okay, I'll give you a theta for a head. And the side length that you're looking across at, that's the opposite side. Right? And then the side length that's right next to you, that's adjacent. That's what it means to be adjacent, like right next to you. So that's how we say, adjacent and opposite. And so sine, we're just going to define the sine of theta to be opposite over hypotenuse. We're going to define cosine to be adjacent over the hypotenuse, which will always be the same ratio for a given angle, right? Because it's a right triangle, and we know this angle, so we know the shape, and we might not know the size, but the ratio of the side lengths will be the same. Okay, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And you know the memory trick that you probably learned in geometry or maybe even in middle school math, I don't know, just depends on when you hit all this stuff, was the SOHCAHTOA, right? So SOHCAHTOA, right? And, okay, remember, like, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. SOHCAHTOA. Okay, this is the memory trick. Now, I will also have another memory trick for you for the other three. So cosecant, that's CSC, is cosecant. Cosecant is basically hypotenuse over opposite. But you're not going to remember that. That's not how you're going to remember it. You're going to remember that it's the opposite of sine. Okay, now you would think that secant was the opposite of sine and cosecant was the opposite of cosine. But that's not how it works. It's the opposite of what you would expect. Secant is the opposite of cosine. It's hypotenuse over adjacent. And cotangent is the opposite of tangent. That's adjacent over opposite. So really, the memory trick I'll give you is actually one of the reciprocal identities for secant, cosecant, and cotangent. It's just a fact that's always true, that cosecant of an angle is equal to 1 over the sine of that angle. That secant is equal to 1 over cosine. And that cotangent is equal to 1 over tangent. So I think we're kind of ready to put this into use. All right, now we're going to need to do some examples and put all of this into action. So the first one, it's basically solve for x, right? And we've got an angle. We've got a 40-degree angle. We've got a side length, okay, presuming that this is a right triangle. Okay, I should probably have drawn that in. But if we've got a right triangle and we know one side and one angle, then we know everything. We've got it all pinned down. We just have to solve for it. So what you're going to have to do is you're going to say, okay, I've got an angle and I've got an adjacent side. Okay, I've got adjacent and I've got a hypotenuse. So you think to yourself, if I've got adjacent and hypotenuse, which trig ratio do I use? If I use SO, no, that's O and H. Do I use TOA? No, that's O and A. Okay, so it's got to be CA, right? So I'm going to say cosine is adjacent over hypotenuse. So I'm going to use the fact that cosine of theta is equal to adjacent over hypotenuse. That's how I'm deciding which trig ratio to use. And then I'm going to write down, write this down with specifics. I'm going to say that cosine of theta, well, not theta, cosine of 40 degrees, so that's the angle I have, is equal to the adjacent, which was 8, divided by the hypotenuse, x. And then I'm going to just solve for x. I'm going to multiply both sides by x, and I've got x times the cosine of 40 degrees equaling 8. And then I could solve for x by dividing by cosine of 40 degrees. So that's 8 divided by the cosine of 40 degrees. But, and this, I guess you could say this is an exact answer, but this doesn't really give you a good idea. I know it's got to be bigger than 8 because it's the hypotenuse and it's the longest side, but I don't know how much bigger than 8. And if I wanted to, get a number, I would need to use a calculator right here. So I'm going to bring in a scientific calculator. And the first thing I'm going to tell you about these scientific calculators is we have to make sure they're in degree mode if we're using degrees right here. Or, if we're given an angle in terms of degrees, we're going to need to use degree mode. Later on, we'll use radians, and if you've been in a pre-calculus class, you've seen radians before, you might understand why, maybe you weren't explained why radians are the kind of the superior measure of an angle. But I'll get to that all later on in this course. Okay? If it's in radian mode, if it says rad at the top, you need to switch it into degree mode. So you're going to go over here and you're going to push mode, and then you're going to, where it was radian, you need to switch it to degree. Okay. And now you're ready to go. And just like always, I'm going to recommend that you type it in just like you see it using the fraction bar. See up here now it says degrees. Okay, so I'm going to use the fraction bar. I'm going to do 8 divided by cosine of 40 degrees. And that'll be 10.443. I don't remember if the instructions on the quiz for next time say to round to 3 decimals or round to 1 decimal or what, but so for this video, I'm just going to round to 3 decimals every time. All right, next I've got one where I've got an angle, I've got the opposite side, and I've got the hypotenuse, which means I'm going to need to use sine. Right? I've got opposite, hypotenuse, so that's sine. And so I'm going to start with the, the trig ratio. Sine of 53 degrees is equal to opposite over hypotenuse, x over 6. And then if you wanted to solve for x, you would multiply both sides by 6 and say x is equal to 6 times the sine of 53 degrees. And that's something that we can bring in the calculator to help with. So here I've got it, 6 times the sine of 53. Make sure you're in degree mode. Press enter, and you get 4.792. Okay, these are the types of kind of classic trigonometry problems that you can really safely expect to see on, like, I don't know, a quiz next time. Okay, I think this next one would be a good one for you to try on your own. So, for those of y'all in class, I'm going to freeze the screen. And for those of you watching at home, you can either just, look away or pause the video or something, because I'm going to be working it quietly. There you go. So first I started with what you see in blue and red. I thought to myself, okay, I've got an angle, I've got an opposite side, and I've got a hypotenuse. That means I need to use sine. Then I set up the ratio. Sine of 29 degrees is opposite over hypotenuse. That's 5 over x. And then I started solving for x. So I started by multiplying both sides by x, and then I divided both sides by sine of 29 degrees. And at that point, that's where you have to bring in the calculator, right, and type it in just like you see it. I always recommend using the fraction bar. And that's 10.313. So maybe we can get one that's going to use tangent here in a second. Yeah, here we go. Here's one that's going to use tangent. So I see I've got, I've got myself like an opposite, and I've got myself an adjacent. So you're thinking TOA. So you start with the trig ratio, right? Tangent of 70 degrees is equal to opposite over adjacent. Okay, you're going to multiply both sides by x. And then you're going to divide by tangent of 70. So x is equal to 16 divided by the tangent of 70 degrees. Okay, that's definitely a job for the calculator. Right, and bring that in. And we're going to do maybe a fraction bar. We're going to get 16. And we're going to divide by the tangent of 70. That'll be 5.824. Here's one where they're going to give you kind of like a minimum amount of information, and then they're going to ask you to solve the triangle. And solve the triangle means like find everything else that wasn't given, right? So I'm just going to start with the information that was given. They said A was 56 degrees, so I can just put that there. And side B was 10. Okay, well, I'll start with the easy part. What is the measure of angle C? What's the measure of angle C? 90, yeah. It's the right angle. It's got 90 degrees. Okay. B, you can solve for B by subtracting 56 and 90 from 180. Okay. That will probably be 34. Yeah. Okay. Now to find A and C, we're going to have to use trigonometry. So I'm going to start with side A. In order to find A, I'm going to kind of reproduce the triangle. So that'll be 56. That's 90. Let's see, we are looking for A, and we were given B equals 10. So we're going to do it just like we were doing those problems earlier. I've got an opposite and an adjacent. Okay, so I've got tangent of 56 degrees equaling opposite over adjacent. So A is going to equal 10 times the tangent of 56. Okay, that's a job for the calculator. So I'm just doing this off to the side. I don't think you need to see me typing in 10 tangent of 56 on the screen. That's 14.826. So I'm going to copy that in, 14.826. Now, for side C, I feel like we have a couple of options here. Okay? I think the first and most obvious thing to do would be to just take that same strategy we've been taking, right, and set up the triangle. This is 10, this is C, that's 56. I've got an adjacent and a hypotenuse, which is set up perfect for cosine. Okay, so that's 10 divided by C. Adjacent over hypotenuse. Okay, you do the algebra steps and you're going to end up with C is equal to 10 divided by the cosine of 56. Okay, 10 over the cosine of 56 is going to be 17.883. But there is another way that we could find this 17.883. Right? It's something we haven't talked about today, but it's something that's true for every right triangle. You could use the Pythagorean theorem. Right? So a different way you could set this up is you could say 10 squared, is it on? Yeah, that's just barely in my window, plus 14.826 squared is equal to c squared. And then I could, kind of bring in a calculator to help with that. So the way I would do that is I would say 10 squared plus 14.826 squared. Find that, and then take the square root of the answer. Okay, so the square root of the answer, I think is that button. Yeah. And that's, again, that's 17.883. So really, however you like it, you're going to get 17.883. And it won't matter, say, on a quiz or a test, which technique you use, because you're going to end up with the right answer regardless. So that's how we solve the triangle. We figure out all the rest of the stuff that wasn't given. Okay, here's something where we've got two side lengths and basically one angle. We know it's a right triangle. We've got two side lengths, and we want to know about sine and cosine and tangent of these, of x, of this angle. And the thing is, we can figure out what x is in terms of degrees. We just don't have that tool quite yet. And that's what we're going to do next time. We're going to do inverse trig next time. And we could figure it out. But the first thing we need, if we say we want sine, sine is opposite over hypotenuse, but we don't have the opposite side. So the first step for us is going to be calculate the missing side. Now for us, we're going to need to use the Pythagorean theorem that 40 squared plus b squared is equal to 41 squared. And I'll save you a little time on the calculator with the arithmetic. I'll tell you that 40 times 40 is 1600 plus b squared. And 41 times 41 is going to be 1681. Okay? Meaning that b squared has to be 81. So b has got to be 9. B is not going to be negative 9. We're not interested in triangles with negative side lengths, at least at this point. So I'm going to replace that with 9. Then, the second step is just going to be use SOHCAHTOA. At least to find sine, cosine, and tangent. Well, I know sine is opposite over hypotenuse, so that's 9 over 40. Okay, cosine is the adjacent over the hypotenuse. That's 9 over 41. So I meant 40 over 41. And tangent is opposite over adjacent is 9 over 40. There it is. Okay, now to get the other ones, secant, cosecant, and cotangent, I'm going to use the reciprocal identities. Remember that, secant is 1 over cosine, cosecant is 1 over sine, and cotangent is 1 over tangent. So, if I want secant, I need to start with cosine. I'm probably going to flip it and just put it over there. So that's, 41 over 40. Okay. Cosecant is the opposite of sine, so it's going to be 41 over 9. And cotangent is the opposite of tangent. That will be 40 divided by 9. And that's how we would do a problem like that. And there's another one of those on your practice problems at kind of the back of this section of the packet. All right, a different kind of problem here that we've got is, you're given one of the trig ratios and you're asked to find the other one, some other one. Okay, so what you're going to need to do first is draw a picture. Can't emphasize that enough. Okay, so you're just going to draw yourself a little, little right triangle here. And what I'm going to do is I'm just going to call this one theta. So if tangent of theta is 4 over 3, we know tangent is opposite over adjacent. So this is 4 divided by 3. Okay. Now if I want secant, I'm going to need cosine. I'm going to need to start with cosine. But to get cosine, I'm going to need the adjacent and the hypotenuse. So I need to find the hypotenuse. So use the Pythagorean theorem. And maybe you know what goes with a 3 and a 4, but 3 squared plus 4 squared equals c squared. That's 9 plus 16 equaling c squared. That's 25 equaling c squared. So that means that this has got to be 5, right? Okay. The 3, 4, 5, knowing the 3, 4, 5 and the 5, 12, 13 would be very helpful for the SAT, ACT. Okay. For this class, knowing 9, 40, 41 might also be useful because that's the one I like to use a lot. Okay. There's also 8, 15, 17, and 7, 24, 25. But those are, I'd say, just remember the Pythagorean theorem for those, rather than just trying to memorize Pythagorean triples. Okay. Now, if I want to find secant, I'm going to first want to have cosine. Okay, so cosine of theta is equal to adjacent over hypotenuse. Therefore, I can say that since secant is the opposite of cosine, that's going to be 5/3. I'll set up another one for y'all to try on your own, this type. Okay, the one for y'all to try on your own will be, if sine of theta is 5 over 13, find tangent of theta. Okay, so I'll kind of get y'all started before I freeze the screen. And what we're going to do is, okay, I know that sine is opposite over hypotenuse. And, wait, that's not 11, that's 13. But I'm going to freeze the screen. If you're watching at home, you should definitely pause the video, because I'm going to pause the recording to keep the video as short as possible. All right, there you go. So I found that the other side length was 12 because I know that 5, 12, 13 is Pythagorean triple. And then I said, well, tangent is opposite over adjacent, which is going to be 5 divided by 12. That's a very common type of trig question, especially when you're just doing triangle trig. All right, now the last thing I've got for you all in this video is an answer to the question, how do I find values of secant, cosecant, and cotangent on the calculator? If you look, you only have buttons for sine, cosine, and tangent. Okay? If you look really closely above them, like on the second, you see sine -1, cosine -1, tangent -1. But that does not mean the -1 power, like flip a fraction, right? And that is one thing that y'all were really good on this year. Y'all know that the -1 power takes a fraction and it flips it, or it takes a number and it turns it into 1 over that. But when we last unit, or maybe a unit before last, when we studied inverse functions, some of y'all got tripped up a little bit. You took that a little too literally. Okay? That's what that means over here. That means inverse sine, inverse cosine. And we'll talk a lot about this in the next class and on the next video. But that is not, so tangent to the -1 is not cotangent. Okay? So what I'm going to say, the answer to this question is, you're going to need to use those reciprocal identities. So if we start out by asking you something like, find me secant of 68 degrees, something like that. Okay. Well, what you're going to have to do is you're going to have to say, well, secant is the opposite of cosine. So this is 1 over cosine of 68 degrees. And you're going to type it into the calculator just like that. Okay, 1 over cosine of 68 degrees. That's 2.669. Okay. I asked you for cosecant of 14 degrees. Okay, well, that would be 1 over the sine of 14 degrees. Okay. And that's, again, that's something that we can do on the calculator. We're going to set up for a fraction bar. I recommend using the fraction bar every time. Okay, over sine of 14 degrees, and that's 4.134. And then cotangent of, let's say, 40 degrees. Okay, well, that'll be 1 over the tangent of 40 degrees. And that'll be, let's just job for the calculator. And that'll be 1.192. And I'm telling you, I mean, if you watch this far in the video, I'm telling you, this is the type of question that will be on the quiz, will be on the test, right? Just find me secant of 68 degrees. Because there's plenty of confusion on that, especially, you know, people's first introduction to trigonometry. How do I calculate these values using a calculator, right? Because there's no button. Hey, but otherwise, that's all I got for y'all in this video. There's plenty of stuff to practice. You know, in your note packet, it says practice problems kind of after these, find the values of the trig functions using the calculator that I just did. And you can practice those if you feel like you need more. But even if you don't, we're going to do those practice problems at the beginning next time before the quiz. So happy studying.